All right, after all these long videos with a lot of math, I'm super excited to show you how to do the pizza example using Excel because it's super easy. But now that we've gone through and I've shown you how to estimate all these different numbers and do all these calculations, hopefully now you'll see them and now you'll easily be able to interpret them and understand them. So this is the result, the output. We're actually going to do it together in Excel. So here's the data, right? You've seen this before. The restaurant, all the restaurants, their population, and their sales. So in order to do regression in Excel, you go up to Data, go over to Analysis, go to Data Analysis, select Regression, hit OK, and here you can enter all of your information that we've seen before. So the Y, remember your Y is your output, so that's sales. So select all your sales data. Again, I select the labels. I think that that's a little bit easier in terms of reading the output. X is your independent variable, that's student population size. I select labels, confidence level. So I didn't do any videos about confidence levels and confidence intervals or anything like that, but it's important, so I select that. Output range, just select wherever you want the output to appear. Residuals, I'll show another video in a little bit on residuals, but for now just select residuals and residual plots. If you read the section on residuals, you can also understand what normal probability plots and standardized residuals are too. But for now, just select what we talked about and hit OK. I'm just going to hit cancel because I already have the output that appeared. So hopefully now you hit OK and you have the output. So I highlighted in a bunch of different colors the output, which we've seen. We calculated all these values by hand. So first of all, we have the regression statistics up top. First, you'll know R and R squared, right? We already calculated. Remember, let's go back in our PowerPoint slide. If we go back to calculating these values, right? The confidence, the coefficient of determination R squared and the correlation coefficient R, right? We calculated those, 0.90 and 0.95. Boom, that's where they are. So in terms of seeing the output and what does it mean, right? Now you know where these values come from. Now you know how to interpret them. So when you see the multiple R, right, you know that this is a correlation between the two variables. The R squared, you know this is the coefficient of determination. It tells you how well your data fit the estimated regression equation, right? And at 0.90, this basically means, remember, approximately 90% of the variability in Y, right, in sales, the outcome variable, is basically accounted for in our regression model that we have. So with the one predictor that we have, student population size. Adjusted R squared, this is more appropriate for when we're talking about when you have at least two predictors. We'll talk about that in the business analytics course. Standard error, remember you had to calculate this to be able to calculate your test statistic, your t-value. And observations, that's just your sample size of 10. Remember when we talked about the F table, right, in terms of we had the t-test and then we talked about the F statistic, and I said, hey, you're going to get an analysis of variance table for your output, right? And we talked about the sum of squares, the degrees of freedom. Guess what? Here it is. It says the analysis of variance. So we have the regression, right? The degrees of freedom, right? So these are just a little bit out of order compared to this table, but all the information is there. So we have the degrees of freedom 1, 8, and 9, 1, 8, and 9. We have the sum of squares, right? Regression, residual, total. Remember, we calculated all those. They're all there. We have the mean squared, right? Error and regression. This is why I always confuse R when it says sum of squares R, and I say residuals sometimes, because I learned it with R being residuals. So that's just a total side note, but in case you're wondering why I always mess that up. And then, right, so we have those mean squared estimates, right? Boom, those are right there. We have our F statistic, and its significance. So all of that information we already calculated. If we go down here, here's our coefficients, right? 60 and 5, right? Our y-intercept and our slope. So again, this slope can be interpreted as 1 unit increase in X is associated with an increase of 5 units in the outcome variable Y on average. So basically, if we have an increase in student population size of 1,000, we can expect an increase in $5,000 in sales on average. We find that that's standard error, it's test statistic, which we already calculated, and its associated p-value, right? So here's the output that you see with a regression. We calculated all of these values basically by hand. So, I mean, this is basically, if you're going to do a regression, a simple linear regression, this is the output that you're going to get, and this is what you're going to want to look for, right? You're going to want to look at your F statistic and its significance, the T statistic and its p-value to see if it's significant. If it is, then you want these values, right, the intercept and the slope, so that you can actually write your equation so that then you can use it for prediction. You want to know how well this equation does overall in terms of fitting the data, so you want to look up here at the R-squared. If you want to know how the two variables are related in terms of strength and direction, you look at the correlation coefficient, which is right here, the multiple R. All right, so you have all of this information at your disposal in terms of interpretation. So it's really simple to do this in Excel. Just go up to data, data analysis, hit regression, enter your data, and boom, there it is. So it's a lot easier to do it in Excel, but I think by doing it by hand, you appreciate what all of these values really mean in terms of breaking it down and understanding it. So some of your homework problems, I actually have you do them by hand so that you can understand them, and then there's a lot of problems that you can just, you have the Excel files and you just plug them in so that you can just have the output and you're able to interpret it. Because ultimately, when you get into the real world, that's what you're going to be doing. You're never going to do this stuff by hand. You're never going to calculate, right, the intercept by hand. You're going to use software to do it. But like I said, by doing it by hand, you really appreciate the output and what it means.